lessons. In today's video, we shall be looking at several problems on differentiation. We shall continue our problems on differentiation. So, if you haven't subscribed to the channel, please do well to subscribe to the channel. Endeavor to turn on your notification bell. And please give us your good comments. We really appreciate you. We love you from Nigeria, please, and also from GER, of course. So please stay tuned. Stay from the very beginning to the end, and do well to ask questions if you don't understand some of the things we do or some of the things we are going to be doing in today's class. Please do well and feel free to ask questions, and I'll be getting to you, reaching out across to you. So please, let's begin quickly. So, what shall we be discussing in today's class? Okay, what shall we be discussing in today's class? We shall be looking at different problems. We shall be looking at different problems. Okay, so in our last video we stopped at question number 20. Today we shall begin from 21. Okay, so let's look at what 21 says. So in question 21, let's start with this. We are asked to differentiate y equals x squared plus 3x plus 2. We are asked to differentiate this, that is to obtain dy dx at x equals 2. At x equals 2. Okay? So, how do we obtain this? The question is simple. So, if you are asked to find the derivative of this function at x equals 2, all you have to do is to first of all find the derivative, obtain the derivative of the function, and thereafter substitute for 2, x equals 2 in that derivative. So what we are going to do is bring our function. Let's bring our function. This is our function. Remember, differentiating a constant, so I'm going to put those rules here. Differentiating a constant, if y is equal to a, then dy dx is equal to 0. Okay? So differentiating a constant will give you 0. Differentiating this term will give you a linear term, will give you the coefficient. Okay? So simply put, dy dx for this function, there is a coefficient here 1. 2 multiplies 1, you end up having 2. Then subtract 1 from the power. 2 minus 1 will give you 1. So this is 2x raised to power 1. Then differentiating a linear term gives us 3. So it is that simple. Differentiating this term, differentiating 2, since 2 is a constant, gives you 0. So when you differentiate this function, the result you are going to have is dy dx equals 2x plus 3. Now what did we do? Let's go over it again. Notice that the power here is 2, the coefficient is 1. 2 times 1 is 2. Subtract 1 from 2 to the power, you end up having 1. And x raised to power 1 is coefficient of x, the linear variable. Are we good? So the coefficient of x, the linear variable, will give you the derivative of this linear term. So differentiating this constant gives you 0. But that is not the problem. We were asked to find the derivative at x equals 2. So once I'm done getting this derivative, I'm now going to bring over here, I'm going to write dy dx, okay? Dy dx at x equals 2. So this means you have to obtain derivative at x equals 2. So dy dx at x equals 2 will be obtained by substituting for 2 when x is 2 into this derivative and adding 3 to your result. Now 2 times 2 is 4. 4 plus 1 and 4 plus 3 will give you 7. So at x equals 2, this derivative will give you 7. Now that brings me to question number 23. So in question number 23, we have several problems. So let's come over here. Let's come over here. Now, in question number 23, there are several problems we need to tackle. So we have A, we are going to differentiate all these functions. So let me write out all the functions. We are given this. We are asked to differentiate that function. Okay? The next function in B, 22b, we are asked to differentiate this function. So I'm going to write out all the functions we are going to be differentiating under 22. So under 22 we have A, B, C, D, E, and F. So let's write out all the questions we are to, all the functions we are to differentiate under that. I'm going to write out C equals square root of x in bracket x squared plus 3x minus 2 all squared. Okay. Then for D, we have y equals x in bracket x plus 1 in bracket x squared minus 4. Okay, and we have for E, we have y equals 1 plus x in bracket x minus 2 all raised to power 3 over 2. Then we have the last question, F. We have F here, y equals 1 plus x in bracket 2 plus x in bracket 3 plus x. So under question 22, let's differentiate all these functions, okay? Let's differentiate all these functions. So I'm going to give me a moment. So, sorry for that interruption. So I'm going to put here product rule. So by product rule, if we have y equals uv, then dy dx, if y, u, and v are dependent on x, then dy dx will be v du dx plus u dv dx. Meaning that to solve this problem, we are going to call one of the functions here u. I've called this one u, and I'll call this one v. Now please take note, you can call either of them u or v, whichever one you choose as it suits you, okay? So I'm going to keep u constant, so let's bring u here. I'm going to keep u constant, and my u is x squared. I'm going to keep it constant and then differentiate v. So what is the derivative of this function? 1 plus x raised to power half. Now the derivative of this function, like I told you in yesterday's class, will be differentiate the mother function and then differentiate the inner function. Now notice that the derivative of this function v with respect to x will be obtained by using half to multiply the coefficient 1 in that function. So I'm going to use half to multiply this, and I'll end up having 1 plus x raised to power half minus 1. Half minus 1, that will give me minus half. Now, I'm going to differentiate the inner function. Of course, when you differentiate the inner function, let me put this a little bit. If you differentiate the inner function here, you're going to have 1. So, if you differentiate the inner function, you're going to have 1. Now, doing that means I have differentiated v. So let me bring the problem over here so that you could see clearly. I'm going to bring the problem over here. So let me bring the problem upward. Now, so let's begin for those who may not understand. So I'm going to put here y equals x squared 1 plus x raised to power half. Okay, now for solving this problem again, I'm going to use two rules. Okay, product rule. And for product rule, please take note, if a function y can be expressed as a product of two functions u and v, such that y, u, and v are all dependent on an independent variable, say x in this case, then the y, the x, will be equal to v du, the x, plus u, the v, the x. Okay? Then, so to solve this problem, I'm going to start with saying let u be equal to x squared and let v be equal to 1 plus x all raised to power half. Okay? So that's where the problem begins. Now, I'm going to differentiate u with respect to x. Differentiating u with respect to x simply means using the power to multiply the coefficient, which is 1 here, and that will give me 2x. Subtracting 1 from the power gives me 1. So 2x raised to power 1 reduces to 2x, and that differentiates that function. Then I'm going to come over to differentiate the v, the x. that is differentiate v with respect to x. And to differentiate v with respect to x, I will be using chain rule. I'm going to be using chain rule of differentiation here. So you will notice that in solving the overall problem, I'm using two rules, the product rule of differentiation and the chain rule of differentiation. So why am I using the chain rule of differentiation? If y, a function of x indirectly, but if y is a function of u and u is a function of x, then the y dx can be expressed as the y with respect to u times the u with respect to x. Okay? So I'm going to be using that rule and this other rule to solve this problem. So I'm going to say for this, I'm going to call it, let's rather use m here since I've already used, I'm going to use m here. So let's change this to m. Now, I'm going to say let m be equal to 1 plus x. And that implies that the m dx will be equal to 1. Remember, differentiating a constant gives you 0. Differentiating a linear variable gives you the coefficient of the linear variable. And what is the coefficient of this linear variable? It is 1. This is a constant, so differentiating it gives 0. Differentiating this linear variable gives you the coefficient, which is 1. So I've gotten the m dx. Now, what is dy dm? Dy dm would be equal to, take note, y, since we've said m should be 1 plus x, then it means that v can be written as m raised to power half. Okay? Now, if you differentiate v with respect to m, you end up having half multiplying m, half from half subtracting 1. And if you simplify this, this will reduce to 1 over 2 square root of m, which is the same thing as 1 over 2 square root of what m is. And m is 1 plus x. So, now, I can now come over here to obtain the v dx. I can now say the v dx is the same thing as the v dm times the m dx. Okay? And that will give me this. That will give me this. That will give me this solution. So let's put it over here. That will give me the v dm is 1 over 2 square root of 1 over 2 square root of okay, let's bring it over here. So the v dm will give us the v dx will give us 1 over 2 square root of x, 1 over 2 square root of 1 plus x times the m dx, which is 1. And that reduces to 1 over 2 square root of 1 plus x. Now that we've obtained the v dx, you can now come over to finalize your result and use product rule. So using product rule, you'll end up having the following. I want this place dry. You end up having the following. You will have v is 1 plus x raised to power half. I'll keep it constant and then differentiate u with respect to x. What did we get the u dx to be? We got it to be 2x. So I'm going to bring here 2x plus u. Our u is x squared, so I'm going to put here x squared. And what is our dv dx? Our dv dx is 1 over 2 square root of 1 plus x. Now, please take note, I often will tell students, nobody really needs you to decompose this. You can leave that as your result in the exam or in any assessment. But if you want to simplify further, you could. So this can be written as square root of 1 plus x in bracket 2x plus x squared over 2 square root of 1 plus x. So I'm going to leave my result in that manner. Okay? So this will be the derivative of y with respect to x for that function. Now, let's move over to the next problem. problem B. Let's move over to problem B. So problem B, I'm going to increase our speed a little so we could meet up with time. So let's go over to problem B. Okay, so now for problem B, we have another function. So now that we know we should be using product rule, let's start with this. So I have this function 4x squared minus 1 all squared. Now I'm going to call this u, I'm going to call this v. Okay, now I'm going to use product rule. Product rule says the y dx will be equal to v du dx plus u dv dx. So I'm going to differentiate, I'm going to use v to multiply the derivative of u with respect to x. I'm going to use u to multiply the derivative of v with respect to x. So let's go without doing so much detail, going through so much detail. So this is v, I'm going to keep v here constant. Keep your v constant. What is v? It is 4x squared minus 1 in bracket all squared. Now what is your du dx? Your du dx is a function of a function problem. So I would advise you do this. In an exam condition, just do this. It is simple. Use 3 to multiply the coefficient here. There are two functions here. 2x plus 3 is embedded in 3. Okay? So this function, this problem gives rise to a function of a function problem. So differentiate the inner function. To get du dx, you differentiate the inner function. Differentiating this inner function will give you 2. So I'm going to put 2 here. Because differentiating the inner function means differentiating 3, which is 0. Differentiating 2x, which will give you 2. Then differentiating the outer function, that is everything raised to power 3, will give you 3 times everything in the bracket raised to power 3 minus 1, which is 2. So when you differentiate this function, that is your u with respect to x, you are going to get this result. So you can try that and see. Now add this to come over here. Keeping u constant, your u is 2x plus 3 all raised to the power 3. So I'm going to put here 2x plus 3 all raised to the power of 3. Now I'm going to differentiate v. Please take note, differentiating v is the same as differentiating a function of a function. Meaning that you have 4x squared minus 1 to be a function embedded in another function, everything raised to the power 2. So to differentiate that function, first of all differentiate the inner function. What is the inner function? It is 4x squared minus 1. Now to differentiate this inner function, differentiating 1 will give you 0, minus 1 will give you 0. Differentiating 4x squared will give you 2 times 4, which is 8. And x raised to the power 2 minus 1, which is x. So when you differentiate the inner function, that's what you're going to get. Now differentiate the outer function. The outer function is everything raised to power 2, and that will mean using 2 to multiply everything in the bracket 4x squared minus 1 and subtracting 1 from this power. Subtracting 1 from this power is 2 raised to power minus 1, and that will be 1. So this reduces to this particular solution. Now, if you want to simplify, we go simplify. So let's simplify. So this will give us 3 times 2 is 6. I will write this as 4x squared minus 1 all squared in bracket 2x plus 3 all raised to power 2 plus 2x plus 3 raised to power 3, 4x squared minus 1. I'm going to bring here, okay, better still, we could just put this as 8 times 2 is 16. I'm going to put here 16x, 2x plus 3 raised to power 3, and 4x squared minus 1. And this is the derivative of this function. Please take note, in solving this problem, we have used 2 rules. The product rule of differentiation and the function of a function rule, which is the same as the chain rule of differentiation. Okay? Now, let's go back to C. Let's go back to C. For C, we have y equals square root of x times x squared plus 3x minus 2 all squared. Now, to differentiate this requires that you use the product rule of differentiation again. V du dx plus u dv dx. Now, I'm going to call this function here u, and I'm going to call this whole function v. Now, according to the product rule of differentiation, I would have to keep my v constant. So I'm going to write this. The y dx is you keeping your v constant. What is your v? X squared plus 3x minus 2 all squared. Okay? And I'm going to differentiate my u. What is my u? The square root of x. Okay? Now, please, I'm going to tell you, this could help you in solving problems quickly. Whenever you differentiate a function like this, y equals square root of x, you need nobody to tell you. I will show you. But the y dx, whenever you differentiate a function like this, will give you 1 over 2 square root of x. Let me show you why. Now, this can be written as x raised to the power half. Okay? Now, if I want to obtain the derivative of this function, the y dx will be using half the power to multiply the coefficient here 1, and that will give me half times 1 is half times subtracting 1 from the power half, and that will give you half raised to power half x raised to power minus 1 over 2, because half minus 1 is minus half, and that is the same thing as writing 1 over 2x raised to power half by indices, which gives you 1 over 2 square root of x. So you don't need to go through all this process in solving a question like that, and that's what I'm going to be doing here. Okay, so take note, v is this, du dx. To differentiate, du dx will require us to differentiate square root of x, and that will give us, from what I've just shown you, 1 over square root of x, 2 square root of x. Now, I'm going to come over to plus, what is your u? Your u is square root of x. I'm going to put square root of x here. What is your dv dx? Your dv dx will lead to a chain rule of differentiation. Okay? Because here you have a function in a bracket raised to power 2. And the bigger function is everything inside this bracket raised to power 2. When you differentiate the outer function, it will be 2 times, this is the same thing. Let me show you what is going on here. So we have x squared 3x minus 2 all squared. Now let's assume you want to differentiate this. To differentiate this means 2 times the coefficient here, which is 2. Put everything as a variable, and 2 minus 1. 2 minus 1 is 1. So you'll be left with 1 here. And everything here raised to power 1 is that stuff. Okay? So I'm going to use that same rule here. So differentiating v will give me 2 in bracket x squared plus 3x minus 2. So, again, I will tell you, if you are solving a problem in your exam, you could leave your answer in this manner. But sometimes they may want you to simplify further, so you could make your answer look a little bit better. So, let's simplify to get a final answer on this. I will write my result as x squared plus 3x minus 2 all squared all over 2 square root of x plus 2 square root of x in bracket x squared plus 3x minus 2. So doing this makes my result look better. Okay? Now, I would want you to go over the video again and again afterwards to see clearly what we've done, just in case you don't understand in detail. So going over it again will help you understand it better. Now, let's look at the next problem. Let's look at the next problem. So, the next problem is problem D. Problem D of 22. So, what does problem D require? We are given x, y equals x plus 1 x squared minus 4 to differentiate. How do you tackle a problem like this? One way to do it is to merge two out of, there are 3 functions here. So you have to reduce, in order for you to apply product rule of differentiation, you have to reduce any 2 of the functions at all to become 1. So the simpler way to go about it is to merge these 2. So I'm going to merge these 2 into one function. So I'm going to call this y equals x times x is x squared, x times 1 is x. So doing this to the problem simplifies it to becoming a product of two functions. Okay, so let's call this function u, and let's call this function v. Now again, by product rule of differentiation, the y dx will give me v du dx plus u dv dx. Now, what does this rule require? It requires us to keep whatsoever our v is constant. So I'm going to bring our v. Our v is x squared minus 4. I'm keeping it constant. And it requires us to differentiate our u. Differentiating u means 2 will multiply 1, the coefficient here, and that will give us 2. So I'm going to put my derivative here. That will give us 2x. Subtracting 1 from the power here, 2 minus 1 is 1, so I will leave this as 2x. Now differentiating this linear variable will give us 1. Okay, so this is all plus 1. Now what have I done? I have differentiated du dx and I've multiplied my result with v. So v kept constant is x squared minus 4. Differentiating u with respect to x gives me 2x plus 1. Now let's go over to u. For u, keep u constant. If you keep u constant, u is x squared plus x. Differentiate v. If you differentiate v, you will notice that differentiating the constant minus 4 gives 0. Differentiating x squared gives you 2x. So you are going to have this. Now if you want to write your result to look better, you could just leave this in this manner. 2x plus 1 plus 2x in bracket x squared plus x. So this is the derivative of this function. Now let's go over to the next problem, E, 22E. So in 22E, we are asked to differentiate this. Y equals 1 plus x, x minus 2 raised to power 3 over 2. So the y dx, again, this problem requires product rule. The first rule we'll be needing here is product rule of differentiation. So this rule again applies and is v du dx plus u dv dx. So that would amount to calling one of my function u and calling this other one v. Now if you keep v constant, your v will be x minus 2 raised to power 3 over 2. Differentiate u, your u with respect to x. When you differentiate u, which is 1 plus x, you are going to get 1 because 1 is a constant, it differentiates to give 0. X is a linear variable, differentiating it gives the coefficient of the linear variable, which is 1. So I'm going to put here 1. Okay? So what I have just done here is keeping v constant, which is this, and differentiating u with respect to x, giving me 1, plus keep u constant. Your u is 1 plus x. Your v, the v dx. Now let's obtain the v dx. Your dv dx can be obtained using function of a function, that is product rule of differentiation. Differentiate the inner function. If you differentiate this inner function, you are going to get 1. Okay? When you differentiate the inner function, you are going to get 1. So let's put the 1 here. Then when you differentiate the outer function, again, please let me show you this. If I differentiate this outer function, my result will be 3. I'm going to have this. Let's bring it over here. So let's assume we have a function m equals this raised to power 3 over 2. So I'm going to differentiate the inner function, which gives me 1, times differentiating the outer function will require me to use the power to multiply the coefficient, which will give me 3 over 2, and subtracting 1 from the power, it will give me half. 3 over 2 is 1.5. So when you subtract 1 from 1.5, it will give you half. So this will be raised to power half. So your result here will be the square root of x minus 2, which is x minus 2 raised to power half, all times 3. So this will be 3 over 2. Okay? Now when you simplify this result, you end up having the square root of x minus 2 raised to power 3. When you re-express this, according to indices, a raised to power m over n is the nth root of a, all raised to power m. So using this rule, you can express this as this, times 1 gives you 1, obviously, plus, coming over here, you can write your result better by putting this 1 plus x and then square root of x minus 2. And that solves problem E. For problem F, let's go back to problem F. The last function we have here says we should differentiate this. So let me clean this. I could clean this off. Let's clean this off and solve problem F, the last problem here. So for problem F, we have y equals 1 plus x, 2 plus x, and 3 plus x, a product of three functions. I would advise you can pick any two functions. So I'm going to pick the first two, merge them to give a new function or a simplified version of the function. So 1 plus x in bracket 2 plus x, when you merge them, they become 1 times 2 is 2, 1 times x is x times 2 is 2x, and then x times x is x squared, okay? And in bracket you have this. Now, you could simplify further by adding up like terms, okay? And that will give you x squared plus 3x plus 2 in bracket 3 plus x. So this is a better function to differentiate. So we are going to call this u and call this v. If we call this u and call this v, then the y dx from this follows the product rule of differentiation. V du dx plus u dv dx. Now, I'm going to keep our v constant. What is our v, guys? It is 3 plus x. What is our du dx? Du dx will require us to differentiate this inner function. Differentiating 2, x squared will give us 2x. Differentiating 3x will give us 3. When you differentiate this, the power multiplies the coefficient, which is 1. Subtract 1 from the power, you are going to get 2x. When you differentiate this, when you differentiate a linear term is a term that has the highest power divisible to the 1. When you differentiate a linear term, the result is the coefficient. So if you differentiate this linear term, the result will be 3. So I'm going to put 3 here. When you differentiate a constant term, it gives you 0, so that goes. Okay? Now, we have multiplied v with the derivative of u with respect to x. So let's go over to u. What is our u? Our u is x squared plus 3x plus 2. Now, what is your dv dx? Your dv dx is differentiating 3 plus x. When you differentiate 3, it gives you 0. When you differentiate x, the linear term here, the coefficient will be the result, and that is 1. Now, let's simplify our result. Having done that, our result becomes 3 plus x, 2x plus 3, in bracket plus x squared plus 3x plus 2. So, that answers all the questions on 22. Now, let's now move over to the next question, question number 23. Let's move over to question number 23. So, welcome to, I'm seeing Henry, welcome, Joseph, welcome, and Excellence, welcome. So, you're all welcome to today's class. Thank you very much for joining. So, let's move over to other problems. So I'm going to continue with problem 23. Let's see. So what does problem 23 say? So for problem 23, we have this. Differentiate y equals x plus 1 all over x minus 1, where x is not equal to 1. So we are asked to differentiate that in A, question 23A. So we have 23B, we are asked to differentiate y equals the square root of 2 minus x all over the square root of 2 plus x for x lying between minus 2 and 2. We are asked to differentiate C, y equals 2x squared minus 3 all raised to the power 3 over x not equal to 0. We are asked to differentiate D, y equals 3 plus x, 3 minus x, all over x cubed, where x again is not equal to 0. We are asked to differentiate E, y equals 4x cubed minus 3x squared plus x plus 1 all raised to the power half, all over x plus 1 all squared, again where x is not equal to minus 1. Then finally f, we are asked to differentiate y equals the square root of 1 plus 2x squared raised to power 3 all over x, where x is not equal to 0. So how do we solve all these problems? Please, these are all differentiation problems that will need you to use primarily the quotient rule of differentiation. You'll be needing the quotient rule of differentiation. Okay? So we are going to be using the quotient rule of differentiation along with one or two more rules to solve each of those problems. So let's see how it goes. Okay? Let's see how it goes. Now I'm going to start with the first one. Let's start with the first one here. Okay? Let's start with A. So if I'm given this to solve, I'm going to be using the quotient rule. Now if y, according to the quotient rule, can be expressed as a ratio of two functions with the denominator of v not equal to 0, then dy dx, according to quotient rule, can be written as v du dx minus u dv dx all over v squared. So we are going to be using this rule. I'm going to put this rule here. We are going to be using it all through for solving the problem. So let's start with the first problem. Now, please take note that in the first problem, if this is the case, if this is what we are given, let's call this the upper function u, and let's call this one v. Okay? So, if u is equal to x plus 1, then the u dx, if you are very familiar with differentiation, will give you 1. Okay? Why is that so? 1 is a constant. When you differentiate it, it gives you 0. X is a linear variable, so the coefficient will be the result of that derivative. So if you differentiate x, you're going to get 1. If you differentiate 1, you're going to get 0. So come over to v. If v is equal to x minus 1, so also would you have dv dx giving you 1. Because differentiating minus 1 gives you 0. A constant term, differentiating x gives you 1. Now, once you are done doing that, you can now implement your dy dx. Dy dx will be equal to v du dx. V is x minus 1. The u dx is 1. Okay? So I'm going to write here x minus 1 times 1 minus u is x plus 1. I'm going to put here x plus 1. The v dx is 1 all over v squared. Your v is x minus 1, so this will be v squared will now be x minus 1 all squared. Okay? Now, if I were to be the one solving that problem, I could leave my answer that way, but I would advise you simplify nevertheless. So, simplifying your problem or your answer gives you dy dx equals x minus 1 times 1 will give you x minus 1 plus or minus rather x in bracket minus plus 1. Okay? Because x plus 1 times 1 is x plus 1. So this will be all over x minus 1 all squared. And that simplifies to x minus 1. Minus times x is minus x. Minus times 1 is minus 1 all over x minus 1 all squared. Which simplifies to x minus x goes. And so you'll be left with minus 2 x minus 1 all squared. Okay? So that solves that problem. I believe we can now go to question B. So for 23B, looking at 23B, you are asked to differentiate this. We will be using the quotient rule all through. We will be using the quotient rule. Now, this function, dy dx, for this function will be v du dx minus u dv dx, that all over v squared. So let's call this our u and let's call this our v. Okay? So our I'm going to bring this one backward a little bit. Dy dx. This will be, to start with, your v squared will be the square root of 2 plus x all squared. Okay? And your v, which is this, will be square root of 2 plus x times your du dx. Now, if you differentiate 2 minus x, let's come over here. If you differentiate 2 minus x, guys, if you differentiate 2 minus x, let's say we are given m equals 2 minus x, square root of 2 minus x to differentiate. Based on what I told you earlier on, when you differentiate a function that is of this nature, m equals square root of a, your result to start with will be 1 over 2 square root of a. Okay? Now, since this problem is not a, rather you're having 2 minus x. Now that you differentiated the outer function to have 1 over 2 square root of a, which is in this case 2 minus x, differentiate the inner function. When you differentiate the inner function, you are going to have minus 1. So that minus 1, if it were here, it multiplies this 1 to give you minus 1. So you end up having your result as minus 1 over 2 square root of 2 minus x. And I'm going to bring that result here. Okay? So minus 1 over 2 square root of 2 minus x. Then minus this minus here. What is our u? Our u is 2 square root, the square root of 2 minus x. So I'm going to put it here. Times, what is our dv dx? Our dv dx, since v is 2 plus x, by a similar thing we've done here, the result you would get will be, you get 1 over 2 square root of 2 plus x times 1, which of course gives you 1. Okay? Now, let me show you again why that is so. So if you had m in this case to be square root of 2 plus x, I've told you the m dx, just like we had in this case, would give you 1 over 2 square root of 2 plus x. When you differentiate the outer function, when you differentiate this inner function 2 plus x, you end up having 1. That 1 multiplies this 1 to give you 1. Of course, you end up having that result. Now, once you are done, you can now simplify your result to get the square root of 2 plus x over 2 square root of 2 minus x minus the square root of 2 minus x all over 2 square root of 2 plus x all over square root of 2 plus x all squared, which is the same thing. When you square the square root of a number, you end up having the number itself. So that is what you would have. If you choose to factorize your business, but at this point in time, once you are told to differentiate, nobody really needs you to simplify to the very last. Once you've been able to apply the rule and simplify at least a little bit, we are okay. Okay? Let's go over to question C. Let's go back to question 23C. So I'm going to bring 23C over here. Now 23C says we should differentiate this 2x squared minus 3 all raised to the power 3 all over x. Okay? Now, I could twist this question using function of a function, product rule. I could also use quotient rule. So let's use quotient rule. Now, dy dx is v du dx minus u dv dx all over v squared. So what is our v? Let's call the denominator here our v. Let's call the numerator our u. So if you differentiate this function, let's see what we are going to get. Our v is x, so we are going to have x squared for v squared. Our v again is x, so I'm going to bring x here times du dx. When you differentiate this function using function of a function or chain rule of differentiation, you are going to have the power multiplying the coefficient. So you end up having 3x squared minus 3. 3 minus 1 will give you 2. So when you differentiate, when you keep v constant, which is x, times differentiating this, you will end up having this. But when you differentiate the inner function, let's differentiate the inner function, you are going to have 4x. Okay? So, if you go further, let's see what we are going to have. Now, we have done our differentiation for this part. Let me write this better. So, now that we've differentiated that part, so I'm going to have here x squared, of course. Now, minus u. What is your u? Your u is the numerator, so I'm going to put here 2x squared minus 3. Your dv dx is you differentiating your denominator there, which is x, and that will give you 1. So if you simplify, you end up having 3x times 4x, which is 12x squared, times 2x squared minus 3 all squared minus 2x squared minus 3 when it multiplies 1 all over v squared. You could factorize if you choose, but I would leave my result in this manner. Okay?
Are we not having 3 there?
Which 3? Let's see which one.
Du in the second one.
Du,
Yeah.
right?
Yes, down.
So
Your last line.
this one,
Last line.
last line.
Yes, check your values.
Okay, let's see again. So we had this, right? This was our u.
Yeah.
2x squared minus 3 all raised to power 3. Now differentiating this gave us 3 times the coefficient, the outer function. Okay, v was x, so we got this x here. Now differentiating the outer function for u, differentiating u with respect to x, 3 multiplying the coefficient here to give us this 3, 2x squared minus 3, then subtracting 1 from the power gave us 2, which is this 2. Then differentiating this inner function gave us 4x minus differentiating 3 gave 0. So that was how we got this. Now minus u was the outer function, so this is where we are supposed to put 3, right?
Yeah.
Thank you very much. So this is where we are supposed to put 3. Good. So we now differentiated v and got 1, right? So this should be 3. Thank you for that observation. So now that was question number C, 23C. Let's quickly move over to question number 23D. Now please, I would love you to go over these problems again and again. They would really help. The solution procedures will really help us. So let's look at 23D. Y equals 3 plus x, 3 minus x, all over x cubed. So quotient rule again will come in handy. So the y dx is equal to v du dx minus u dv dx all over v squared. Now what is our v? I'm going to call our v here x cubed, and I'm going to call our u the numerator, everything there. So differentiating, keeping v constant will mean keeping x3, x raised to power 3 constant. Differentiating, I'm going to put my v here, all squared, right? Then du dx, differentiating the outer function there, the upper function, this is my u. I'm going to be using product rule to differentiate my u. So using product rule, I would have to do this. So I'm going to put this here. Let me keep my v constant, and I'll use product rule to differentiate that. Or you could even make the problem simpler for yourself. Take note, this is difference of 2 squares. According to difference of 2 squares, 3 plus x in bracket 3 minus x will give you 3 squared minus x squared. So that is 9 minus x. More or less the numerator is 9 minus x. 9 minus x squared. Okay? So if you differentiate 9 minus x squared, what you'll be having will be 9 minus x squared, differentiating 9 minus x squared will give you minus 4 minus 2 minus 2x. So that's what you're going to have. Now what did I do? Please take note. 3 plus x, 3 minus x comes from a plus b, a minus b. This is a squared minus b squared. So this is difference of 2 squares. And that would mean 3 squared minus x squared. Okay? And 3 squared is 9, x squared, so you end up having 9 minus x squared. And if you differentiate 9, it gives you 0. If you differentiate minus x squared, it will give you 2 times minus 1 minus 2 raised to power 2 minus 1, which is 1. So you end up having minus 2x. So that's how we got this result. Now, if you come over here and then subtract u, what is our u? Our u is in bracket 3 plus x, 3 minus x, which I'm going to call, in this case, 9 minus x squared, just like we've done. Okay? And what is differentiating our v? Our v is x cubed. If you differentiate our v, you end up having 3x squared. Okay? So simplifying your result now, you have x cubed, that is rather minus 2x raised to the power 4 minus 3x squared in bracket 9 minus x squared all over x raised to the power 6. I could write this result in a better form. If I bring out this minus, it comes here to become plus, so this I can write as 3x squared in bracket x squared minus 9. I can rewrite that result in that manner, minus 2x raised to the power 4 all over x squared, and x raised to the power 6, sorry. So this will be your dy dx. Now you go over it again, check. Let's now go quickly to the next question. The next question is E. Question E. For question E, we are asked to differentiate this. For question E, that is 23E. We are asked to differentiate 4x cubed minus 3x squared plus x plus 1 all raised to the power of half all over x plus 1 all squared. Now, I'm going to call the numerator my u, call this my v. Okay? So differentiating y with respect to x would mean using quotient rule. Your v in this case is x plus 1 all squared. So I'm going to bring that here. All over my v squared, x plus 1 squared raised to power 2. Okay? Then, since I've kept my v constant, I'm going to differentiate my u. Now let me bring this one upward. Let me write this. My u, differentiating my u will give me, differentiating the outer function, half times 1 is half. So I'm going to have 1 over 2 square root of all that is in this bracket, 4x cubed minus 3x squared plus x plus 1. Okay? That is using the idea of function of a function. Differentiate the outer function. Whenever you differentiate anything raised to power half, the result will give you 1 over 2 square root of that stuff. Okay? Now, if you now differentiate the inner function, differentiating the inner function will be times 4. Differentiating 4x cubed will give you 12x cubed and 12x squared. So I'm going to put that here, 12x squared minus differentiating 3x squared will give you 6x. I'm going to put that here. Then this is plus x, I presume, plus x, right? That's plus x, yes. Differentiating x will give you 1, and differentiating 1 will give you 0. So that's what you are going to have for v du dx. Now come over to u dv dx. U dv dx would mean having the following. It will mean having the following. For u dv dx, we are going to have this. This is x plus 1 all squared. I'm bringing that here. So u dv dx, you are going to have u. What's our u? Our u is 4x cubed minus 3x squared plus x plus 1. Okay? And our v, our dv dx, is differentiating the denominator, which is the same thing using product rule, or rather chain rule. You are going to differentiate the outer function 2 times the coefficient, which is 2x plus 1 raised to power 2 minus 1, which is 1. Then differentiate the inner function, you are going to have 1. Okay? So that will end up giving us all this over 1. So you can write your result as x plus 1 all squared in bracket 12x squared minus 6x plus 1 all over square root 2 square root of 4x cubed minus 3x squared plus x plus 1 minus 2x plus 1 in bracket 4x cubed minus 3x squared plus x plus 1. So all over 1 all over x plus 1. 2 times 2 will give you 4. Now please take note, what I've done in the denominator comes from this rule of indices. A raised to the power m in bracket n is equal to a raised to the power mn. Okay? So by that rule, the powers will multiply to give this final result. You could simplify further if you so choose. Okay? But we have actually differentiated that function. Now let's go to the next and the final one, that is f, right? We're in f. So for f, let's see how we differentiate f, the final function here. So let's see how we differentiate f. So for f, we are told y equals square root of 1 plus 2x all squared raised to the power of 3 all over x. Okay? So if you are to find the y, the x, we are going to be using quotient rule also. You could use product rule. You could manipulate that expression to become a product of two functions, but we are going to be using quotient rule. So let's call this function here v, and let's call the numerator u. So I'm going to keep v constant. V is x. I'm going to keep it constant, and I'm going to differentiate u. If you differentiate u, so let me bring this down a little bit. If you differentiate u, you are going to have 1 over 2 square root of 1 plus 2x squared. Okay? If you differentiate, let me put this better. So keeping v constant, I'm going to put v squared here, which is x squared. I've kept my v constant. So I'm going to differentiate my u, the numerator. That will be 1 over the square root of, that will be 1 over 2 square root of 1 plus 2x squared, all raised to the power of 3. Now, I could go further to differentiating the inner function. If I differentiate the inner function, there is another inner function, everything raised to power 3. So I'm going to differentiate that, and that will give me 3 in bracket 1 plus 2x squared raised to power 2. Then if I differentiate the innermost function, I'm going to have 4x. Okay? So all these, I'm going to extend this a bit. All these minus. Let's now differentiate. That was differentiating, keeping v constant and differentiating x. So you check out that, okay? Differentiating v with respect to x, or differentiating u with respect to x. So let's now keep u constant. Keeping u constant means keeping this constant, 1 plus 2x squared all raised to power 3, and differentiating, keeping u constant, differentiating v. If you differentiate v, you're going to get 1. So that will now give us a simplified result. 4x times x will give us 4x squared times 3 will give us 12x squared. So I'm going to write here 12x squared in bracket 1 plus 2x squared all over 2 square root of 1 plus 2x squared all raised to power 3. Of course, this can cancel 12 to give us 6. All over x squared minus, in the numerator, we are going to have square root of 1 plus 2x squared all raised to power 3. Okay, so that solves all the problems in question 22 and 23. Now, I'm going to continue my series, of course, on solving differentiation problems in differentiation. I'm going to continue with these problems. We are going to be moving ahead with so many other problems, and tomorrow we are going to be starting much more earlier than how we started today. Sorry for keeping you waiting, for those we kept waiting. We are going to start earlier tomorrow, and we are going to solve so many problems in tomorrow's class. So do well to join tomorrow's class. Please like the video, share the video, of course, and drop your good comments. I'll be seeing you. God bless you all. Good night.